All right, so this is Unit 4, lesson number 15. We're talking about the slope of a non-vertical line. So slope is something you've already heard me talking about a little bit. And let's dive into it a little bit more because we need to have a really solid understanding of slope before we can graph any lines. So what exactly is slope? Slope is a numerical value representing the steepness of a line. So if you look at these examples of lines here, we will see that they've got different steepnesses, including the fact that some of them are heading down and some of them are heading up. And so what I will tell you is I'll actually give you the slopes of these, and then we can talk about we can talk about sort of the range of slopes that you could find. Okay, so as it turns out, we'll talk about how to calculate this at another point, but basically what we have here is this slope is actually going to be -2, and we do use the variable m. I know that seems strange, but that's the variable that we use. The second one has a slope of -1/3. The third one actually has a slope of 1/2, and the fourth one actually has a slope of +4. And so what we can actually see here is that slope can be put sort of on a number line. And it turns out that if you go very far to the left, the more into the negatives you go, this is steeper, spell it right, steeper and decreasing, meaning heading down from left to right. So a picture of that might look something like this, very steep. In the middle, we have not as steep, but still decreasing. So that might be something like this. Then we have, when we get past 0, it's not as steep and increasing. So now the line is going up as we go from left to right. And then as the number gets bigger and bigger and bigger, it gets a lot steeper and it's increasing. Okay, something like that. So what you have here is if you have a very negative number, -2, -3, -4, and on and on and on, that's going to be pretty steep and it's going to be decreasing, going down as you read it from left to right. Smaller numbers like fractions, so -1/2 or even -1, that might be considered, it's not quite as steep. It's kind of flatter, but still decreasing. And then we move past 0 and we have small numbers like 1/2, 1/3, 1. And those are not quite as steep, but increasing. And then as you get big numbers, 2, 3, 4, 5, that would be really steep and increasing. So that's sort of how this works. Okay. Now, how do we actually calculate the slope of a line? Well, the first thing you have to do is you have to choose 2 points on the line. Okay, so choose 2 points on the line. Typically, we're going to choose nice points, like ones that land. We're going to try and avoid fractions and things like that if we can. Then we are going to calculate the rate of change, which is your slope. And if possible, we are going to reduce. So sometimes you get a fraction. We're going to reduce that if we can. So let's look at a couple of examples of this. Here we go. I'm going to zoom in. Okay, what is the slope of the line shown? Okay, the first thing we're going to do is we're going to choose 2 points. Right away, I see 0, 0. Oh, that's a nice one. think we're going to take that one. And then I notice this point right here falls right on a nice intersection. So I'm going to take that one. Now, you could have just as easily have chosen maybe this point right here or any other point that falls on an intersection, maybe that one. You just want to find 2 points, and you generally don't want to find a point that falls like in the middle of a box if you can avoid it. It's just easier. So what we want to do is we want to calculate the rate of change. So we basically want to figure out how far is this going up or down, and then how far is it going left or right. Okay, so that's what we're going to do. So I'm going to start on the right-hand point, the one that's more on the more on the left. I'm going to start more on the left, and I'm going to move to the point that's on the right. So the first thing I'm going to do is I'm going to go down. So as I would have to go down 1, 2, 3, 4, 5, 6. I would have to go down 6, and then I would have to go from there. I would have to go to the right 1, 2, 3, 4. I would have to go to the right 4. And now I'm going to put that into a fraction. So down 6, so my slope down 6 would be -6, and to the right would be +4. So if I'm going down, I'm going to make it negative. If I'm going up, I'm going to keep it positive. And the bottom is always to the right, so we'll just keep that as positive. And now I can reduce that. Your calculator can reduce fractions for you, but this actually reduces to -3/2. And that's going to be the slope of that line. Let's look at another one. First step, choose 2 points. So I've got a nice point right here, and then I've got another nice point. I'm going to choose this one right here. Okay, so start at the leftmost point. We want to read from left to right. So I have to go up 1. So that would be up 1, and then to the right, 1, 2, 3, 4, 5, 6. So I have to go to the right 6. So if I put that in a slope, up is positive and right is positive. So that's 1/6. Now that can't be reduced. So that's as far as I would go with that. So we want to choose 2 points, calculate the slope. It's how far do I have to go up? How far do I have to go down? And then how far do I have to go to the right in order to get from one point to the next? Put those in a fraction, and that's it. That's how you find slope.